Chapter 5 Wallets. The word wallet is used to describe a few different things in Bitcoin. At a high level, a wallet is an application that serves as the primary user interface. The wallet controls access to a user's money, managing keys and addresses, tracking the balance, and creating and signing transactions. More narrowly, from a programmer's perspective, the word wallet refers to the data structure used to store and manage a user's keys. In this chapter, we will look at the second meaning, where wallets are containers for private keys, usually implemented as structured files or simple databases. Wallet Technology Overview. In this section, we summarize the various technologies used to construct user-friendly, secure, and flexible Bitcoin wallets. A common misconception about Bitcoin is that Bitcoin wallets contain Bitcoin. In fact, the wallet contains only keys. The coins are recorded in the blockchain on the Bitcoin network. Users control the coins on the network by signing transactions with the keys in their wallets. In a sense, a Bitcoin wallet is a key chain. Tip: Bitcoin wallets contain keys, not coins. Each user has a wallet containing keys. Wallets are really keychains containing pairs of private-public keys. Users sign transactions with the keys, thereby proving they own the transaction outputs. The coins are stored on the blockchain in the form of transaction outputs. There are two primary types of wallets, distinguished by whether the keys they contain are related to each other or not. The first type is a non-deterministic wallet, where each key is independently generated from a random number. The keys are not related to each other. This type of wallet is also known as a JBOK wallet from the phrase, just a bunch of keys. The second type of wallet is a deterministic wallet, where all the keys are derived from a single master key, known as the seed. All the keys in this type of wallet are related to each other and can be generated again if one has the original seed. There are a number of different key derivation methods used in deterministic wallets. The most commonly used derivation method uses a tree-like structure and is known as a hierarchical deterministic or HD wallet. Deterministic wallets are initialized from a random sequence. To make these easier to use, random sequences are encoded as English words, also known as mnemonic code words. The next few sections introduce each of these technologies at a high level. Non-deterministic wallets. In the first Bitcoin wallet, now called Bitcoin Core, wallets were collections of randomly generated private keys. For example, the original Bitcoin Core client pre-generates 100 random private keys when first started, and generates more key as needed, using each key only once. Such wallets are being replaced with deterministic wallets because they are cumbersome to manage, backup, and import. The disadvantage of random keys is that if you generate many of them, you must keep copies of all of them, meaning that the wallet must be backed up frequently. Each key must be backed up, or the funds it controls are irrevocably lost if the wallet becomes inaccessible. This conflicts directly with the principle of avoiding address reuse by using each Bitcoin address for only one transaction. Address reuse reduces privacy by associating multiple transactions and addresses with each other. A Type 0 non-deterministic wallet is a poor choice of wallet, especially if you want to avoid address reuse because it means managing many keys, which creates the need for frequent backups. Although the Bitcoin Core client includes a Type 0 wallet, using this wallet is discouraged by developers of Bitcoin Core. Tip: the use of non-deterministic wallets is discouraged for anything other than simple tests. They are simply too cumbersome to back up and use. Instead, use an industry standard-based HD wallet with a mnemonic random sequence for backup. Deterministic wallets. Deterministic or seeded wallets are wallets that contain private keys that are all derived from a common seed. through the use of a one-way hash function. The seed is a randomly generated number that is combined with other data, such as an index number or chain code, to derive the private keys. In a deterministic wallet, the seed is sufficient to recover all the derived keys, and therefore a single backup at creation time is sufficient. The seed is also sufficient for a wallet export or import, allowing for easy migration of all the user's keys between different wallet implementations. HD wallets, BIP32, BIP44. Deterministic wallets were developed to make it easy to derive many keys from a single seed. The most advanced form of deterministic wallet is the HD wallet, defined by the BIP32 standard. HD wallets contain keys derived in a tree structure, such that a parent key can derive a sequence of children keys, each of which can derive a sequence of grandchildren keys, and so on, to an infinite depth. HD wallets offer two major advantages over random non-deterministic keys. First, the tree structure can be used to express additional organizational meaning, such as when a specific branch of subkeys is used to receive incoming payments and a different branch is used to receive change from outgoing payments. Branches of keys can also be used in corporate settings, allocating different branches to departments, subsidiaries, specific functions, or accounting categories. The second advantage of HD wallets is that users can create a sequence of public keys without having access to the corresponding private keys. This allows HD wallets to be used on an insecure server or in a receive-only capacity, issuing a different public key for each transaction. The public keys do not need to be preloaded or derived in advance, yet the server doesn't have the private keys that can spend the funds. Seeds and mnemonic codes, BIP39. HD wallets are a very powerful mechanism for managing many keys and addresses. They are even more useful if they are combined with a standardized way of creating seeds from a sequence of English words that are easy to transcribe, export, and import across wallets. This is known as a mnemonic, and the standard is defined by BIP39. Today, most Bitcoin wallets, as well as wallets for other cryptocurrencies, use this standard and can import and export seeds for backup and recovery using interoperable mnemonics. Let's look at this from a practical perspective. Which of the following seeds is easier to transcribe, record on paper, read without error, export, and import into another wallet? A seed for a deterministic wallet in hex, 0C1E.A1A. A seed for a deterministic wallet from a 12-word mnemonic, army, van, defense, carry, jealous, true, garbage, claim, echo, media, make, crunch. Wallet best practices. As Bitcoin wallet technology has matured, certain common industry standards have emerged that make Bitcoin wallets broadly interoperable, easy to use, secure, and flexible. These common standards are: 1. Mnemonic code words based on BIP39. 2. HD wallets based on BIP32. 3. Multi-purpose HD wallet structure based on BIP43. And finally, multi-currency and multi-account wallets based on BIP44. These standards may change or may become obsolete for future developments, but for now, they form a set of interlocking technologies that have become the de facto wallet standard for Bitcoin. The standards have been adopted by a broad range of software and hardware Bitcoin wallets, making all these wallets interoperable. A user can export a mnemonic generated on one of these wallets and import it into another wallet, recovering all transactions, keys, and addresses. Some examples of software wallets supporting these standards include Blue Wallet, Bread Wallet, Copay, and Multibit HD. Examples of hardware wallets supporting these standards include keep key, ledger, and Trezor. The following sections examine each of these technologies in detail. Tip: if you are implementing a Bitcoin wallet, it should be built as a HD wallet with a seed derived from and encoded as a mnemonic code for backup, following the BIP32, BIP39, BIP43, and BIP44 standards, as described in the following sections.